Welcome to our new video. The Geogebra file for this is kept here. That is the link from I will put it on the comment box from where you can access the file. In our previous few videos we have already demonstrated how Gtsimplex look like, how the Gtsimplex are constructed from a given line segment. Suppose one given line segment L is there, and when it changes, the whole story changes. All connected, geometrically connected line segments also change. So for every geometrically connected line segments, we can say that these are entangled line segments. Whatever the distance between two or more entangled line segments, they will get communicated at infinite speed, because the rule of construction moves much faster. We assume that the rule of construction runs much faster than light. We assume it in that way, such that even the two line segments are entangled geometrically through the rule of construction. Then the rule of construction is the law of nature, which can communicate at infinite speed and can update all the line segments who are already connected in any Gtsimplex or already connected in any locked set, will get updated accordingly instantaneously. This is the fundamental concept of rule of construction. The nature follow the rule of construction, nature follow rule of geometry, and rule of geometry is not same as rule of algebra. Rule of algebra can or ordinary algebra has a rule which follow the commutative law, associative law, but the rule of construction and rule of geometry follow the non-commutative law but associative laws. Because suppose on the left side we have constructed one point after another point, and then line segments and then circles, which are the rule of constructions, and we cannot change the rule of construction, then whole thing will break. Here you can see that the controller objects, when it is moved, all the things instantaneously move with that. These are loose sets, so they are moving freely, they are not entangled. But the moment they are entangled like this with the rule of construction, then when one parameter is changing, all other parameters also change. Like this, we are moving the point P, the pivot point here, it is moving all the things together because all the things are entangled, and we cannot move any of these points independently because these things are locked, and all these things are locked with the rule of construction, with initial line segment L and the seed angle. Whatever the jungle of line segments are there, all are entangled with only this L and the value of seed angles. So we can assume that geometrifying trigonometry is strictly the entangled form of many points, many line segments, and they are not loose things like this one. They are not loose objects, they are all very tightly connected objects. Today we will discuss about how these kind of expressions are also trigonometry expressions, and several large number of triangles are hidden inside these kind of expressions. And every of these terms, when the power series kind of things are there, then several terms are added. Whenever we find this plus inside the terms, we consider these plus are of forming quadtree, that is every plus has a 4 symmetry, and every of these terms have a numerator and denominator form. When the denominator is not available, we consider it as 1, that is the initial line segment. L is the initial line segment, and that is 1. Suppose for this side also the Gtsimplex is formed, where numerator is the output line segment and denominator is the input line segment. For simplicity we can consider it as one is the hypotenuse, which is the input line segment, that is L is the input line segment, and perpendicular is the output line segment, and these two things combiningly forming a triangle. This triangle is a simplest form of the Gtsimplex, the most simple starting thing of Gtsimplex. And when it is represented in this way, the right hand side, when it is represented in this way, this whole thing is the locked set, and all the line segments are connected with 1, the initial line segment on both sides. Here also 3 into 2 into 1, factorial 3 is 3 into 2 into 1, x into x into x. In the numerator we can see that x into x into x, so we can consider x by 3 into x by 2 into x by 1. Whatever the value of x, that is the length of some line segment of a triangle, and 3 into L is the line segment of a triangle. So x by 3L is representing one triangle, and that triangle is glued with another triangle whose sides are x as the output and 2 as the input, and that is also glued with another triangle where x is the output and L, that is 1, is the input. In this way we can consider these as 3 triangles are glued and forming one Gtsimplex. Here we can consider 5 number of triangles are glued and forming a Gtsimplex, and we have seen that this kind of ratio always give a final output line segment and initial line segment. So this kind of Gtsimplex, any kind of Gtsimplex, will have one initial line segment which is common for every term and one output line segment. All plus minus are done with the output line segments are aligned or naturally aligned. If they are naturally aligned, then this expression, whole expression, is naturally summable. If they are not naturally aligned, then forced alignment is also done. We have already explained how the summation and subtraction can have different kind of behaviors of symmetry. Plus has 4 different symmetry, minus has 4 different symmetry, and those are natural symmetries. We can do 2 different kinds of forced summation or forced subtraction, that is called cumulative summation or forced aligned summation. If you need, then we will generate different videos also on forced summations. Especially we have already made 2-3 videos on which we have explained the fundamental natures of these kind of summations. Multiplication and division are very crucial things in geometrifying trigonometry, because multiplication and division handles the Gtsimplex very specially, and whatever we do, ultimately one initial line segment is getting entangled with one output line segment, and all other line segments are the supporting line segments, like these kind of dotted lines which are all supporting line segments, intermediate, and everything get updated instantaneously. The rule of construction moves the instructions, takes the instruction from the rule of constructions are moving at the higher speed than light we can expect, and it can update all the line segments involved in the locked set instantaneously. So wherever the line segments are there, even they are outside the galaxy, they are all connected with rule of construction of nature with the initial line segment. And so whatever the rule of construction is used, when it is changed, or when any parameter like seed angle or the position of initial line segment is changed, then all of the line segments will readjust its positions as if they are instantaneously entangled through rule of construction. In this way, we can think that any kind of expression like these are the controlling of Gtsimplex and locked sets. I repeat again, the expression like these on the right hand side forming the locked set, and locked set has a difference than Gtsimplex. The terms are Gtsimplex, which are like glued triangles. I want to show you how these kind of things look like. This is an independent line segment, and due to some rule of construction, I am not showing all the rule of construction here. I am showing that line segment construction our loose line segment constructions are done here, such that we can show you how the rules of line segments. We should move this far away, otherwise it is not snapping the points, and if the points are not snapped, you cannot see the constructions of these lines. Now these lines are glued, but that is not following proper rule of geometrifying trigonometry, so they are allowed to rotate. It is not a good thing as per geometrifying trigonometry, but I am trying to show you the way things are getting locked. Suppose when I am moving this line segment, these 2 points are also moving, and accordingly all the other lines are also moving. In the same way, we can construct other line segments also. In this way, we construct the glued triangles, and this whole thing turn into the Gtsimplexes. And this is not Gtsimplex because this is not constructed with the rule of construction as per trigonometry. But when all these line segments are constructed as the rule of construction of geometry, then we call these as the Gtsimplexes. Here we cannot call it as the Gtsimplex because these are constrained objects, but these are not Gtsimplexes in reality. But yes, if we can define these things with trigonometry expressions such that all these line segments are interrelated trigonometrically, then these kind of free things will not be available, because the constructions will follow some other rules. And in advanced Gtsimplexes, sometimes these kind of cases also occur. We will show it in separate videos, but this is not actually a Gtsimplex. Here I was trying to show you the nature of the triangulated objects we can see in Gtsimplexes. Yes, these kind of things are possible to represent as trigonometry expressions like these. These are also the trigonometry expressions. Suppose x is a tan theta or sec theta or cos theta, then these kind of trigonometry objects will turn into a trigonometry expression. But x is also anything, because tan theta has a special property. It can take any value from minus infinity to plus infinity. Any real number is expressible as tan theta. We can express as -1 to +1 with tan theta and cos theta and sin theta. In the same way, we can take any value from 1 to infinity with tan theta, and also with some other ratio like sec theta or cosec theta. In the same way, we will have the different theorems with which we explain when to take what kind of ratio to get best kind of Gtsimplexes and best kind of locked set. So in this video, we should tell you that points are the minimal form of Gtsimplex. Line segment is also the one of the part of Gtsimplex. The part of relationship is very important kind of relationship in logical analysis and logical understanding. Triangle, any triangle is a simplest form of structural and functional form. Simplest structural and functional form of Gtsimplex is a triangle. Every triangle, we can think that there are 3 angles. One is the minimum internal angle, one is intermediate internal angle, and another is the maximum internal angle. Suppose in a right angle triangle, if there are 2 other angles in a right angle triangle, then one is less than 45 degree, another is more than 45 degree, or both are 45 degree. In case of both are 45 degree, then we can consider any of them as a seat angle. But the best convention in geometrifying trigonometry is to take the minimum angle that is formed in any triangle is taken as the pivot angle, and that is the seed angle. The maximum angle, maximum internal angle which is formed inside any triangle is taken as the stretch angle. That is, in right angle triangle, that is normally 90 degree or pi by 2, which is the maximum internal angle in right angle triangle, that is the stretch angle, and another angle which is not minimum nor maximum but intermediate, any value, that is 90 minus theta, which is taken as a nodal angle. And in this definition we have covered any kind of triangle as a gluable triangle, and multiple number of gluable triangles can form the Gtsimplexes. And Gtsimplexes has a special property. Gtsimplexes are the part of locked set. Locked sets are not the part of Gtsimplexes. I repeat, Gtsimplexes are part of locked set. Locked sets are not part of Gtsimplexes. We can do plus minus into divide with Gtsimplexes also. Here we can see that every term are Gtsimplexes, and we can do plus minus with Gtsimplexes, and multiplication and division of Gtsimplexes are also there, and I have already told in previous videos. In next several videos we will also demonstrate the multiplication and division of the Gtsimplexes, multiplication and division of locked sets. I will surely describe in detail about those things. And if suppose this whole right hand thing is in the numerator of one expression, and suppose this kind of thing, this right hand kind of thing is in the denominator of some same expression, then both of these are ultimately having a output line segment, and these also have output line segment. These two output line segments in that case will combine to form a triangle. So division of a locked set with another locked set will form a triangle. The multiplication of one locked set with another locked set will also form the glued triangle. For the case of Gtsimplexes also, when we multiply two Gtsimplexes, that is ultimately one output line segment of the first Gtsimplex is taken as the input line segment for the next Gtsimplex, and the whole process continue. In that way we can glue two different Gtsimplexes to get a bigger Gtsimplex, and that is the multiplication of Gtsimplexes. The addition of Gtsimplexes is to put the output line segments of first Gtsimplex in front of another line segment of the Gtsimplex. Suppose this one is the output line segment of the first Gtsimplex, and this one is the output line segment of the second Gtsimplex. Then we can simply put this like this. Then it is the cumulative addition of two Gtsimplexes, and just as imagine a large Gtsimplex, a large number of triangulated object is connected with this, and this one is the output line segment of first Gtsimplex, and imagine that another big large triangulated object is connected with this, where this line segment is the output line segment for the second Gtsimplex. And when we will put these two like this, or when we will put these two like this, then their addition, and sometimes you can feel that the subtraction is done with the reversing this whole thing and putting that in this way, the start to end way or end to start way. In this way we can do the addition or subtraction of the Gtsimplexes, and ultimately it is also gluing at the point. When the Gtsimplexes are added or subtracted, they glue at the point, at the end points of output line segments, and when Gtsimplexes are multiplied, then the whole Gtsimplexes are glued. When Gtsimplexes are divided, one Gtsimplex is divided with another Gtsimplex, then output line segment of the numerator is the output line segment of a triangle, and in output line segment of the denominator is the input line segment for a triangle, and then you connect these endpoints with a point, and in this way we can get the division of two Gtsimplexes. So you could understand here that how the Gtsimplexes division work. And in the same way, suppose this one is the output line segment of one locked set, and this one is the output line segment for another locked set, and you have already seen, and I have already demonstrated you that either it is a Gtsimplex or either it is a locked set, everything are constructed from common line segment L every time. The triangulated expression are different, so the construction protocols are different, but all the Gtsimplexes, or that is all the terms of the locked sets, are constructed with only one single line segment, that is the initial given line segment. And so all of these line segments, whatever it is, even two line segments are at the end of two different sides of the galaxies, they are all entangled because all of these are coming from the same single initial line segment, and all of these are controlled with the same or different seed angles, but those are parametrically controlled. All line segments are parametrically controlled, and all these line segments in the Gtsimplexes and in the locked sets are interlinked with the rule of trigonometric expression, so they are all entangled. In this condition, we can easily understand how the behavior of plus minus into divide works, and we can easily see how the geometrifying trigonometry can explain any kind of triangulation, even the Delaunay triangulation, even the Voronoi diagrams, and whatever the kind of things in the finite element analysis, or in mesh analysis, or in computer graphics, or in network flow analysis, wherever it is. If the line segments are interlinked, suppose it is this line segment is the output line segment for any Gtsimplex, and this is represented, this one is the initial line segment, and all the line segments are trigonometrically interrelated, then ultimately this line segment is related with this one, this is related with this one, so ultimately these two are interrelated, and we can consider every line segment is directly or indirectly related. And this kind of relatedness through the trigonometry expression is forming a Gtsimplex. And when this same kind of thing, when this same kind of glued triangulation is added at any point with due to the alignment or end-to-end placements of output line segments, then that forms, suppose there is another Gtsimplex of this same type, and its end point is glued here because this is the output line segment, and there is also another output line segment. Suppose this one is the output line segment of another Gtsimplex, then placing these things with where a big Gtsimplex is coming with this, then this whole thing will turn into a locked set. I think you have understood how to think about the Gtsimplexes and locked set, and we have given an overview of plus minus into divide of Gtsimplexes and plus minus into divide of locked sets. So arithmetic of Gtsimplexes is explained in this video. The arithmetic of locked set is also explained here. First of all, we should clearly understand that aligning, gluing and scale to fit is very important part of Gtsimplexes, and whatever interaction we do in case of Gtsimplexes or in case of locked sets, we do that only with line segments. Points don't play big role in geometrifying trigonometry. Line segments are the important player for the plus minus into divide. We can think line segments as vectors, but those are not actually vectors, because force symmetry are not taken care in vector, nor the division of two vectors are defined. But in geometrifying trigonometry, division of line segments is defined as the numerator is a line segment which is the output line segment, and denominator is the input line segment, and these two line segments are placed one with another like this to form a triangle. So ultimately triangle is also Gtsimplex. So when we divide one Gtsimplex with another Gtsimplex, we get another Gtsimplex, that is a triangle. And when this triangle is constructed, we can assume that all the other lines, attached lines, are also coming together, but only visible, strongly visible line segments are the numerator outputs and the denominator, the numerator outputs and the denominator outputs. These two outputs are ultimately the line segments. So we can see these kind of triangles are forming with huge number of line segments are already entangled with this one. When we move one line segment, the all other entangled line segments in the locked sets will move with that, or all other line segments attached with the entangled with this line segment in the Gtsimplex will move with it, and in that way we will get a huge bunch of line segments, and that will form another big Gtsimplex. And we have seen that there is a gluing behavior of line segments to forming a triangle whenever we do multiplication of Gtsimplexes or division of Gtsimplexes. Ultimately, in the multiplication of Gtsimplexes and division of Gtsimplexes, we get Gtsimplexes. But when we do plus or minus of Gtsimplexes, we get locked sets. And when we do the multiplication of locked sets, that is also a final output line segment is interacting with the final output of another line another locked set, and in that case we can see there is a gluing behavior, and in that case we will also get a locked set multiplied with another locked set. Looks like a locked set, but there is a very large gluing behavior. But Gtsimplex is simpler object than locked set, and locked set is very important because when we try to handle the expressions like sin theta plus cos theta plus tan theta whole to the power 6, then sin theta plus cos theta plus tan theta makes a locked set. It is not a Gtsimplex. Suppose we are trying to talk about expression like sin x into cos x plus cos x into tan x plus sec x into tan x whole to the power 3. This kind of thing is a locked set into locked set into locked set, because within the bracket there are plus terms, and whenever there is a plus term or minus term in the bracket or in any whole expression, then it is a locked set. That is the secret to identify the behaviors of the locked set. But in the Gtsimplexes, these kind of plus terms or minus terms are not there. These are the multiplicative form. Suppose this kind of expression where everything are in the multiplicative form, and these things are Gtsimplexes divided by Gtsimplexes. We can think it in this way. But this part is locked set because plus and minus, the loose additions are done, so it is a locked set. And where we can glue the points in locked set cases, we can see the points are glued, but in case of Gtsimplex multiplication or Gtsimplex division, we can see the line segments are glued. And division is a special case where the output divided by input is handled in that way. And ultimately, geometrifying trigonometry is a story where is a mathematical model, mathematical way of reasoning, where geometric reasoning is more important and construction protocols are taken care in that way, and algebraic expressions are also handled as the geometric expressions, and we deal everything trigonometrically. Then we make a triangulated things, and in that way we get large number of line segments, and from that, through machine learning or through other process, we can derive large number of theorems which were not covered in last 3300 years. I repeat, in last 3300 years we were not constructing geometry from trigonometry expression, so we could not get the insights regarding how the line segments are placed, how the behavior of the entanglement of line segments occur naturally due to trigonometry expression, and we were not bothered about the 4 symmetry cases for every multiplication. We were not bothered for 3300 years that there are 4 symmetries in every plus, minus, into, divide cases in any algebra or in any geometry. Geometrifying trigonometry is the first subject where we do the geometric reasoning, and since geometric construction are non-commutative in nature but associative in nature, so all the rules of algebra will not work properly, and we can get deeper insights, and we will get more number of fundamental theorems, like Pythagoras theorem is one fundamental theorem. In that way we can get large number of fundamental theorems where parallelograms construction is natural. Sometimes the concentric circles will form, that is also natural. Suppose in a Gtsimplex we will see in several cases that we will find several circles will form which are passing through particular 3 line points, and that will also pass through many other points. These kind of theorems will also come in Gtsimplexes and in locked sets. For particular values of seed angles, number of concentric circles will decrease to 1 or 2 or 3, and sometimes for some values of seed angle we will see that every different maximum number of these concentric cycles will come, because not more than 3 points will pass through a single circle. These kind of cases will occur for some kind of Gtsimplexes. So we can say that we have not yet bothered with so many kind of theorems which we could explore if we would think the things as a geometric construction system. Geometric plus minus into divide systems were not properly defined. The division, mainly the multiplication and division of line segments, not vectors. The line segment multiplication division were not discussed previously before geometrifying trigonometry. So we could not model the whole entanglement of line segments before geometrifying trigonometry was done. Now we have described the plus minus into divide situations for Gtsimplexes and plus minus into divide situations for locked sets. Now I think we should proceed with the examples of school level trigonometry and school level geometry, and we should come up with more and more examples from our textbooks, such that students and researchers and engineers all can get deeper insights. Now from the next videos onwards, we will try to explain with the examples from textbooks, such that people can get the flavor, real flavor of how the Gtsimplexes and how these locked sets of geometrifying trigonometry can give better insights, and that can give the deeper theorems in our daily life. We are wishful that someday we will get more detailed information about electromagnetic theories. We will get more detailed understanding on the genetics. Due to the locking behavior of several line segments have some natural laws due to 4 symmetries, and these 4 symmetries entanglements were not discussed before. Now geometrifying trigonometry is very rigorous, and it discusses about these plus minus into divide in a quad tree. Like for every nodes of the syntax tree and the deduction tree will have 4 branches, because 4 different symmetries are taken care to get the exhaustive geometric representation for line segments positioning, line segments alignments, and that will give us deeper insights on the geometric nature of trigonometry expression. That will give us better and bigger and deeper understanding on the geometric nature of these kind of exponential series or infinite series or any kind of series, such that we can examine the natural summability and forced summability conditions for any kind of algebraic expressions also, by constructing them as trigonometric objects and triangulated objects, such that we will get deeper understanding and deeper theorems on our algebraic expressions and also on the geometric expressions. Moreover, the entanglement of line segments and entanglement of points on a plane are not very absurd thing. It is quite natural if we assume a simple thing, that the rule of construction and the rule of updation of all the line segments and all the points is naturally having infinite speed, and the rule of construction can update everything fastest possible, and even it is much faster than light. It can carry the rules of constructions because it is embedded inside the process of construction. It takes no time to carry the information of construction protocol from one point of galaxy to any other point of galaxy. We assume in that way that when the line segments are all coming from the single given line segment with the single rule of construction, then the speed of light is not the point of concern. The point of concern is the rule of construction. If nature is following the rule of construction, then it will give the highest priority for the speeds of updating all its elements, so that its rule don't break up. So the rule of construction is important, and nature follow the rule of geometry. Nature don't follow the rule of algebra, and nature always have a tendency to follow the force symmetry, and force symmetry is a very natural thing. So we should not take everything as a commutative, and we should not ignore force symmetry. If we ignore force symmetry conditions for every plus, minus, into, divide, then we will not get the deeper understanding of the reality of the nature. Thank you.